Lesson 33, solving for the angle using trigonometry ratios. All right, so now what we're going to be doing is actually solving for, well, the angle in a situation like this, right? And to tell you the truth, we've kind of done this in the past, right? We've been doing this for a long time. If I was to ask you, let's say if you had something like tan theta is equal to, I don't know, 3 over 4. Well, what would you do there? Well, you'd say, okay, if I'm looking for the angle, then I would go theta is equal to tan negative 1, the inverse of tan, of 3 over 4, and then just solve from there, right? Like actually that would go into your calculator, right? So now what we're going to do is we're going to be using things that are on the unit circle, and we're going to be able to get some exact values out of this, because what will happen if I put theta in there, this is going to give me a decimal that isn't an exact number, right? It's going to be like an irrational number, okay? But, typically we would just kind of round that, right? Because in this case, that would be 869, yada, yada, yada degrees, right? Add that in degrees. But we just round that to like 36.9 or something, right? But we're in math and we're going to start, being really accurate about these things, okay? So here, let's actually just jump into a question here, and I'll kind of show you how things are going to change based on, the unit circle now. So for what values of theta does the angle, or for what values of theta does tan theta equal negative root 3? And then they give us the restriction, right? And they give us the restriction in radians. Okay, so that means that my answer should be in radians as well. All right. So let's see if we can make sense of where this is, right? Even where these angles would be. So, all right, so tan is really y over x, right? I got to try to make sense of this. So tan theta, I should say, is equal to y over x. Okay, so what's my y and what's my x? All right, well, let's see if we can work with that. First off, let's use our cast rule. Okay, so if we're using cast, then this is negative, right? So where would that be negative? Well, that's going to be negative here and here in quadrant 2 and 4. Okay, so we're saying where is tan theta equal to root 3, negative root 3? Well, you know what? Let's look at our formula sheet and see if we can figure this out. So negative root 3. And remembering that tan is really x over y. Oh, not formula sheet, unit circle. Okay, so we said that it was going to be, in this quadrant and in this quadrant, right? All right, so let's start up in this quadrant. So I want to end up with negative root 3, and it's supposed to be y over x, right? So remember that this is my y, and that's my x, okay? So can you see how this would work out right here at 2 pi over 3? Because if I said tan theta is equal to, and then what if I did this? What if I went, y over x, but instead of a y, I wrote what y was there. What if I wrote root 3 over 2 divided by negative 1 over 2? Do you see how the 2's would cancel there? Like if you change that to root 3 over 2 times negative, and then dividing by a fraction is the same as multiplying by the reciprocal, so that'd be 2 over 1. My 2's cancel, and then I end up getting negative root 3. Okay, so it looks like I was after this one. That's where tan can be a little bit tougher, is you have to figure out, what made it into root 3, right? So, but I think that's it. So in the first part here is it seems like it's happening at 2 pi over 3. All right, where else is this happening? Well, I think it's happening probably, in this quadrant again, but probably here, right? When y is negative root 3 over 2 and x is a half, because that would be negative root 3 over 2 and then over a half. And that too would be equal to negative root 3. Okay, so that's happening at 5 pi over 3. All right, so now we know that. So it's happening at 2 pi over 3, and 5 pi over 3. Okay, so then from here we can say that theta is equal to 2 pi over 3 and 5 pi over 3. And that's pretty much it, because our restriction was between 0 and 2 pi. Well, that's one time around the circle, right? And both of those were one time around the circle, right? So there was my first angle, right? So this angle here was 2 pi over 3. And then the second angle was here at 5 pi over 3. And I haven't gone to 2 pi yet, right? So I'm still within my restrictions there. Okay, moving on to the next one. Okay, so for what values of theta does cosecant theta equal root 2? All right, so now what I recommend is whenever you get something like one of the reciprocal functions, like cosecant or secant or cotangent, is change this into one of our like sine, cos, or tan, because those are easier to locate on our unit circle. So cosecant is the inverse of sine, right? So I'm going to rewrite this as 1 over sine theta is equal to root 2. Okay, so that still doesn't actually make sense, because root 2 isn't on the unit circle, right? Let's play around with this a little bit though, right? I'd like to get sine theta out of the denominator. So what if I rearrange this to say sine theta is equal to 1 over root 2? Okay, now 1 over root 2 isn't on my formula, or isn't on my unit circle either. But what if I play around with it a little bit more? This would be the same thing if I rationalize this as root 2 over 2 on the top, right? I'll multiply the top and bottom by root 2. So that would be the same thing as root 2 over 2. Hey, that one looks good, right? We do know where that happens. So again, where is sine theta equal to root 2 over 2? Right? Another way of saying is, where is y equal to root 2 over 2? Okay, so let's go back to our unit circle here. So where is y, where is sine equal to root 2 over 2 and positive root 2 over 2? Okay, well, looks like it's here, right? That's where y is equal to root 2 over 2. And remember, y is the same thing as sine theta, right? We kind of went through that instead of y, you can think about that as being sine theta, right? So it's equal to it there. It's also equal to it over here, right? Well, that makes sense, because that's like both my y's are above the axis there, right? They're both at root 2 over 2. Okay, so our two answers here, and sorry, that one wanted it in degrees. That's what our restriction was in. So that was at 45 degrees, and then it was at 135 degrees, right? So it was this angle, and then it was that angle. Okay, so that would just be, yeah, between 0 and 360. So the answer there would just be theta is equal to 45 degrees and 135 degrees. All right, solve the following. Okay, so these ones are actually really similar. To begin with, though, we're just going to have a little bit of algebra to do before, right? So just like you would normally do, right? If this sine theta was just, let's say, x, and you were solving for x, well, then you would add 5 and you divide by 4, right? You guys are good at that now. We're going to do the same thing. We're going to get sine theta on its own, get all that rest of that stuff over there, and then see if we can make sense of it. All right, so this is going to be 4 sine theta, and then I'm just going to add 5 to both sides, right? So this would be equal to 8. Okay, and then divide by 4. So divide by 4. All right, so where is sine theta equal to 2? Okay, so where is that? Well, let's look at it for a second. The unit circle. Where is sine theta equal to 2? So remember what we're dealing with here. Sine theta is our y. Where is our y equal to 2? Well, really nowhere, is it? Because if you look it up here, it's equal to 1 at the top, 2 would be, you know, off our unit circle. It'd be up there. So where on the unit circle is this equal to 2? Well, it's not. And if you guys, for this question, sorry for the jumping around, actually, you know, put in your calculator, because at this point, we could solve this like we have been for years now. You could say, okay, theta is equal to sine -1 of 2. And what do we get? We get an error, right? Which means that doesn't exist. That's not on the unit circle. It doesn't actually work out for us, right? So you would say that there is no solution in that case, right? All right, let's do the next one. So the next one says, where is cotangent? Or what's the answer for cotangent here? And then just careful on this one, because it says the angle is between 0 and 4 pi, right? So 4 pi would mean it goes around the circle 2 times. Okay, so we're going to have a few answers for this one now. So let's handle this like cotangent was like x, right? So if those were both x's, well, what would you do? You'd try to get your x's to the same side and the numbers to the other, wouldn't you? So we'll do the same thing. We're going to subtract 6 cotangent theta from both sides, right? So those cancel, and we have like -6 cotangent theta. So 7 minus 6, so that just ends up being cotangent theta, like 1 cotangent theta. And then I'd add 4 to both sides. So this would be equal to 1. Sorry, I should say -1. All right, so now we have like a basis for this, right? So now we're going to say, okay, where is cotangent theta equal to -1? All right, so like I said, if we have it written as cotangent or one of the reciprocal functions, write it the other way, right? So we're going to rewrite this cotangent as 1 over tan theta is equal to -1. Okay, and if I rearrange that, that actually ends up just being the same thing, doesn't it? Because if I, you know, get cotangent up and divide by -1, we just either way end up with tangent theta is equal to -1. Okay, so now where does that happen, right? So remembering that tangent theta is my y over my x. Okay, so where is my y over my x equal to -1? Where is my -1? Well, what about this, right? So if this is my y and that's my x, then, okay, if I go root 2 over 2 divided by -√2 over 2, what would that be equal to? Well, that'd be equal to -1, wouldn't it? So that's a good candidate. So looks like it's 3 pi over 4. And then while we're at it, you know, we see that again down here, don't we? Root 2, so this would be -√2 over 2, like our y, over our x. So then that's going to be at 7 pi over 4. So 3 pi over 4 and 7 pi over 4. All right, so we get theta is equal to 3 pi over 4 and 7 pi over 4. All right, so are we done? No, we are not. We are not done because it was 2 times around the circle, right? That was only 1 time around the circle. So we should have, well, really probably 2 more answers, right? Because, you know, sorry, I'm flipping back and forth here too many times, but I'm imagining, so this was one of my answers, right? Wouldn't you expect that we'd be able to come around the circle and land on that one again? That would be coterminal with that one, wouldn't it? And then we'd have the same situation down here, where 1 time around the circle would get me there, and then I could go around the circle again and hit it again, right? So I have to account for those 2 situations, going around twice. Okay, so how do I go around the circle again for each of those? Well, really, it's going to be our 3 pi over 4. 3 pi over 4. And then I just need to add 2 more pi, right? That would be around the circle another time, wouldn't it? So that would be equal to, well, here, let's actually do it right. So this would be 4, so that'd be multiply the bottom and the top by 4. So that'd be 3 pi over 4 plus 8 pi over 4, which makes sense, right? Which is equal to 11 pi, 11 pi over 4. Okay, so that's one of our answers too. So this would also be 11 pi over 4. And now I'm just going to have to do the same for 7 pi over 4. So we'll just do one more time here. So we'll have 7 pi over 4 plus 2 pi I'll just give you the answer on this one, is 15 pi over 4. Okay, so then it was also 15 pi over 4. Sorry, my color selection was funny there. Okay, so those are my 4 answers, my 4 solutions to this. Okay, next one. Okay, so now this time we have sine squared theta is equal to 0.5. So now this is probably the first time that we've seen this, right, with a sine squared theta. Now, with trig functions, we do it kind of funny because this, when it says sine squared theta like this, what that actually means, it's the same thing as writing this, sine theta, and then all of that squared. So whatever the answer is, square it. But we just have like a specific notation with trig functions. Like this is typically the way you write it. All right, so let's see if we can make some sense of this one. So let's rewrite this a little bit. So let's actually write it that way. We'll write it as sine theta squared is equal to, and then instead of 0.5, let's write that as a half. Okay, and we're between 0 and 180. All right, so if I want to get theta on its own, let's take the square root of both sides. So I will square root both sides. So we end up with, well, squaring a square root, we just get sine theta is equal to, and now square root of 1 over 2 is the same as 1 over root 2. Okay, we've seen this trick before, haven't we, where we get 1 over root 2. Remember what we did? We rationalized the top and the bottom, and we got something a bit more familiar there. So this would be sine theta is equal to root 2 over, and then root 2 times root 2 is just 2. Okay, so the question really says, where is sine theta equal to root 2 over 2? So sine theta is equal to root 2 over 2. I just want you to see it. We should start getting good at memorizing these ones, right? But here and here, that's where sine theta is equal to it. So it's going to be at pi over 4 and 3 pi over 4. So that's going to be when theta is equal to pi over 4 and 3 pi over 4. Oh, sorry. We wanted that in degrees, didn't we? Okay, well, let's go back. So that was equal to 45 degrees and 135 degrees. All right, let's do this one. So where is secant x equal to this? Okay, so this one's definitely not in the unit circle, right? As soon as I see this, I know this is going into my calculator. Okay, so let's rewrite this. Instead of secant x, I'm going to write that as 1 over cos x. And I'm using x, right? But that's the same thing as theta. Sometimes we just write it as x, so don't be confused by that. Okay, so it's that is equal to negative 1.3421. All right, so I'm going to rearrange this, right? Bring my cos x up and divide by that. So we get cos x is equal to 1 over negative 1.3421. Okay, so all we can do here now is just use our calculator, right, to do the inverse operation. So this is going to be x is equal to, and then cosine negative 1 of 1 over negative 1.3241. Okay, so if you put that in, what do you get? So we end up with 142 degrees. What the heck does that mean? 142 degrees. And so is that it then? So what's happening here? Let's think about this for a second. So if we were using our cast rule from before, right? So cast. And we were looking at secant, but really that meant we were looking at cos as far as where is it negative and positive. So this was negative. So cos was negative here and here, right? It was in 2 and 3. So what is this 142 degrees that came under your calculator? Well, that wasn't your reference angle, was it? That was actually the angle from here to here. Okay? And it's up to us to understand what we were given. So your calculator always does that. Your calculator will always start at the positive x, and then it will find its way to the closest terminal arm, right? So it found that is my closest terminal arm, was 142 degrees. But I know that there should be two answers here, right? There's two places where it's negative. So it's also going to be an answer down here. Okay, so how can I find that? This is, your calculator won't do this for you. This is up to us. Okay, so we're going to have to figure out what our reference angle is there. Okay, so we need to figure out that one as well. So our reference angle, so let's find that first here. Yeah, so we'll say, okay, our reference angle, often, denoted as alpha, like that. And it is equal to 180, right? Because 180 degrees would be all the way across, so 180, and then minus our 142 degree angle, so minus 142. Okay, so our reference angle would be equal to 38 degrees. Okay, now why is that useful? Is because if my reference angle is 38 degrees, then so is this one, right? That's also 38 degrees. Okay, so that angle there would have to be 180 degrees plus my reference angle of 38 degrees, which is 218 degrees. All right, so what are my two answers here? Well, my answers are x is equal to, which again, that's just the angle, but x is equal to 142 degrees and 218 degrees. Okay, so that's kind of the gist of it. Now, we're going to keep doing the same thing, but we're going to be finding a general solution. So we talked about this a couple lessons ago. So I'll show you what I mean when we get there. So let's solve this guy. Let's solve this one. Now, this one looks a little funny, right? We haven't really dealt with this type of thing yet, have we? So here's what we're going to do. For a second, just so this looks a bit more normal, let's replace the tans with x's. Okay, so let's say that this was the same thing as just x squared minus 3x is equal to 0. Okay, now if I asked you to solve this, right, what would you do? Well, you'd factor out an x. Okay, so you'd factor out an x, and then we'd have x minus 3 is equal to 0. And then what would you say? You'd say, okay, well then x is equal to 0 because of that one, and x is equal to 3 because of that one, right? We're going to do the same thing, but remember those x's really were tan thetas. Okay, so this is really tan theta times tan theta minus 3 is equal to 0. So all that's really going to change here is I'm just going to have two different solutions based on this thing. So I can look at this one and say, okay, solution number one is when tan theta is equal to, well, 0, right? That was when x was 0. So let's say there's situation number one. And then situation number two would be when tan theta was equal to, well, 3, right? To make that true. All right, so now we're just going to solve these. All right, so yeah, I'm actually going to split these guys up now. So we're going to handle these on their own. You're going to draw a line down those. Okay, so looking at this first one, where is tan theta equal to 0? So again, this is a unit circle question, right? So where is tan theta equal to 0? Now, let's just kind of write down what tan theta is, right? Tan theta is equal to y over x. Okay, so where is this equal to 0? Well, that's going to be when it's 0 over, well, 1 or anything really. That's what's going to make it equal to 0, right? So I want my y to be 0. So really I can change my perspective here and say, okay, where is y equal to 0? Because wherever y is 0, that's where tan theta is going to be equal to 0. Okay, not where x is equal to 0, right? Because if y was 1 and x was 0, so let's say like in this case, right, then that would be 1 over 0. That's not 0, right? That's infinity, or that's not even infinity. That actually just doesn't even work, right? That's not a solution. Yeah, so we are looking for where y is 0. Okay, so where is y 0? So y is going to be 0 here, and it's going to be 0 here, right? So it's going to be at 0 degrees and 180 degrees. All right, so good enough. So for this one, the angle would be at, it's going to be at like 0 degrees. It's going to be at 180 degrees. And if you want to, we can keep on going with this pattern, right? We could say it's also going to be at 360 degrees again, and then, 540, and then 720. And actually, we could have gone the other way too. This also could have been, theta. And this could have started at negative 180, right? And went around. So those are all solutions. So this is why we're doing the general solution, right? The general solution is going to include all of this, right? So one way that we can do this is by saying the angle is equal to 180 degrees times n, where n is a member of the integers. So just check that out for a second too, right? So where n is a member of the integers, so remember that could be like, -1, 0, 1, 2, all the way up, right? Where if I threw in -1 in for n, okay, well that'd be 180 times -1, that'd be 180, or -180. If I threw 0 in there, okay, that'd be 180 times 0, that'd be 0. If I threw 1 in, I think you see where I'm going here, right? If you threw 1 in, you get 180, 2 in, you get 360. So that does seem to do it. All right, so now let's look at the second part here. So tan theta is equal to 3. And remember why it was equal to 3, right? It's the same thing as when you were here. We said x is equal to 3, right? Because, you'd say x minus 3 is equal to 0. Like, where does that happen? So that'd be when x is equal to 3. Okay. So, all right, so we have that set up. So where does this happen? Well, really nowhere on the unit circle, but we will have places, though, that, because like in the other situation where we had sine theta is equal to 2 and it just didn't exist, that's because you can't go higher than like the rate. Yeah, you can't go higher than that. But there are going to be places, because tan is just the ratio of the backside divided by the front side, right? So there will be places where the backside of my triangle, let's say, is 3 times bigger than that side. It won't actually be 3, but it would be 3 times bigger than this. So that will work. We just don't know what it is. It's not one of our nice numbers. So in this case, we're just going to go theta is equal to tan -1 of 3 and figure out what the angle was just using our calculator. Ooh, and one thing to mention, if this didn't work on the last one, you guys are in trouble with that, remember that your calculator needs to be in either degree mode or radian mode, right? So you need to be, start getting pretty good at switching back and forth, because as you've seen, we will need to be able to do both, right? So right now we're dealing with degrees, so you should be in degree mode. And if you're using a TI-84, then that is just under the mode button up by the second button. Okay, so yeah, hopefully that you guys figure that one out. But either way, when you do this, you would end up getting 71.565, and then it's ... right? Because this just actually continues on forever. So we could say that it was approximately equal to 72 degrees. Okay, and for our purposes, we'll just go with that. We'll say it's 72 degrees. Okay, now, that's actually not the whole story, is it? Because, well, think of our cast rule. So we were wondering, where is tan theta, or what is theta when tan theta is equal to 3? And it's positive, right? So cast. So tan is positive here and here. Well, what was this 72 degrees? So remember, like I said, what your calculator does is it goes from the positive x-axis and it goes looking for the closest terminal arm. And that's here, right? So that was the closest one it could find. So that was 72 degrees, okay? It's up to you to know what this angle is here, right? Because this is also an angle from there to there, okay? So you're probably seeing where I'm going here. This would just be 180 degrees plus our 72 degrees. Okay, so that would be 100, our second angle. So here I'll call that angle 1. And this will be angle 2 for a second. So this will be 180 degrees plus 72 degrees. So our angle 2 is going to be 252 degrees. All right. So now I need to make this a general solution for this side too, right? So here, let's just kind of look at what we're dealing with here. So well, actually that might not even help. So if I'm looking at my chart again, right? So if I'm looking at my 72 degrees, right? Well, can you see here that this line here would go around, right? And then hit that one, and then go around, and then hit that one, and then go around, and then hit that one. And that would be the general idea here, right? So there's more and less awkward ways to do this, because I could say, all right, one of my answers is 72 degrees plus 360 n, right? Where I would just go from there and around, there and around, there and around, right? And then do another one for 252 plus 360 n, right? So I'm starting here and then going around and then going around, right? But it's going to be nicer. It's going to be more elegant if we actually just combine these into one, right? So why don't we say this? Why don't we say the angle would be equal to 72 degrees, so we'll start there, and then just go 180 degrees, right? So we'll go plus 180 degrees times n, where n is a member of the integers, okay? And just make sure that that handles it, right? Because, so 72 plus 180n, so let's say if I threw 1 in there, okay, that would get me to here. If I threw 2 in there, well, that would be like 360. That would get me back to where I started. I can even throw negative numbers in, right? So if I go, well, here, actually, let's throw 0 in. If I threw 0, that would be 72 plus 0. That's where I started. If I did a negative number, well, now I'm just going backwards. I mean, I'd be at that one. So that does work, right? So that is also a general solution. So now you had two. There's actually two different answers here. You'd have to have them both. This would be an answer, and that would be an answer. All right, so last one here, I'll try to be a little bit quicker because I rambled for a bit on that one. But so, okay, same idea as the last one, right? We want to really factor out a cosecant, right? We can't see it, so we want to see it. Okay, so you can imagine that they're x's, right? Or we could just kind of go from it, like if you can see it, that would be cosecant theta times, and then that would be cosecant theta minus 3. And that's equal to, oh, shoot. I lied. You know what I did, guys? Sorry. Scratch that. I thought that was a 0 on that end. Let's handle this a little different. That's what you would have done. This is equal to 0, but it's not. So I'm going to bring that 10 over to this side. See what we're dealing with. So this is cosecant squared theta minus 3 cosecant theta minus 10 is equal to 0. So we're going to handle this a little different now, right? Maybe you see where we're going. Instead of cosecant thetas, just for a second, let's do this. Let's call those x's. So this is like x squared minus 3x minus 10 is equal to 0. I bet you could solve this, right? So we're going to factor this. So this is an x and an x. So numbers that multiply to 10 and add to negative 3. So this would be 2 and negative 5. So just remember, though, that this was really, instead of x's, those were cosecants. So we've got cosecant theta plus 2 and cosecant theta minus 5 is equal to 0. So just like last time, here's our two answers here. So it's going to be from this one. So that would be, where is cosecant theta? Here, I'll write the whole thing. It'd be cosecant theta plus 2 equal to 0, right? That was the idea. So that would be cosecant theta is equal to negative 2. Okay, so that's one of them. And then here's the other one. So that would be, where is cosecant theta minus 5 equal to 0? Or, in other words, where is cosecant theta equal to 5? Okay, now both of these aren't going to work out that well. Actually, no, the one won't be too bad. So cosecant theta, well, that's sine, right? That's the reciprocal of sine. So that's 1 over sine theta is equal to negative 2. So rearranging that, we would get, okay, where is sine theta equal to negative 1 over 2? And that one is on the unit circle, right? So that one would be, where theta is equal to 7 pi over 6 and 11 pi over 6. If you can't remember that one, just check out your unit circle. But yeah, that's where it's equal to negative a half. And actually, you know what? I think it would be worth actually looking at that one just for the next part here. So, right, so it's going to be at 7 pi over 6 and 11 pi over 6, right? So that was 7 pi over 6. So that was this one, right? That was that angle. And 11 pi over 6 was that angle. Okay. So now this one's actually a little bit awkward, isn't it, right? Because the last time, right, we were able to start, you know, here or wherever it was and then add 180 and add 180. And this one's not going to be so nice, right? Because we're starting here. And then I have to add like this awkward amount. And then like, so actually we can't turn this into one general answer, right? So we actually have to do it in 2 different steps, which is okay, right? So we're going to start here and then we're going to add 2 pi, right? And then 2 pi n, so we can keep going around. And then we're going to do it again for this one. So we would add 2 pi and then 2 pi and then 2 pi. But we have to do them individually because they don't really go together nicely. Okay, but that's okay. So now we're going to say, okay, so for both these situations, the first one would be, here I'll say angle 1 is equal to 7 pi over 6 plus 2 pi n, right, going around the circle, where n is a member of the integers. Okay, so there you go. There's one of them. And the second one, angle 2, was the other one, right? So that'd be 11 pi over 6 plus 2 pi n, where n is a member of the integers. All right, so we're half done. We did the first one there. So now the second one was for this, right? Where is cosecant theta equal to 5? Okay, so I'm going to rewrite this as 1 over sine theta is equal to 5. So where is sine theta equal to 1 over 5? And nowhere really, right, on the formula or on the unit circle. But we can put this one in, right? This one would be theta is equal to sine -1 of 1 over 5. Okay? So theta is going to be equal to 0.201. Now, remember what angle I'm measuring this in, right? These are in radians. So even though this wouldn't have a unit like radians, sometimes it's helpful to just remind yourself we're talking about radians. So if you put that in and you got like, you know, a bigger number than that, you probably put it in degrees, right? So radians. Change your calculator mode, okay? Now, where is this? What am I talking about when I do this? So let's get our bearings here. So I'm going to do my cast rule and say, okay, where is sine theta positive? What's positive there and is positive there? So this 0.201 radians, that was this, right? It found the closest terminal arm from the x. So that is 0.201 radians from there to there. Okay, which would make this also 0.201 radians, right? That's our reference angle. So anyway, that was one of them. And then we have the other one there. So that would be, well, to figure out what that angle was from here to here, well, we're going to have to go, you know, 180 minus that, but not 180, right? Because we're dealing with radians. So we're going to have to go pi minus our reference angle. So for our other angle, that's going to be pi minus 0.201. So that would be 2.940 radians. You can write radians if you like. Okay, so we're pretty good there, right? I'm not going to put boxes around those yet because those aren't my general solutions. We just have to do the same as we did last one, right? So I'm looking at this one. So angle 3 this time is going to be equal to 0.201 plus 2 pi n, where n is a member of the integers. Okay, so there you go. We got 3, and then we got one more we got to include. Angle 4 is going to be equal to 2.940 plus 2 pi n, where n is a member of the integers. All right, phew, that was a long one. So just to make sense of that, right, what I just did there, that 0.201 was here, right? So when I added 2 pi n every time, what that did was that got me around the circle once. And then, you know, if my m was 2, then that would be around again, and then around again, and then around again, okay? And then just the exact same thing for my other angle there.